Hello, and today we're going to talk about how to solve for the total voltage, current, and resistance in a parallel circuit. Now, as if you remember from our previous video on series circuits, we have to use Ohm's law, which is V equals IR, velocity equals current times resistance, and we use this table over here to solve for all these values. Now let's take a look at this parallel circuit here. We have 10 volts running through a battery, which is connected to the whole circuit. We have a 10 ohm resistor here, a 20 ohm resistor here, and a 30 ohm resistor here. Now let's get started. So the first things first, we have to fill out the table with all the known values. So we have V equals IR, we have resistor 1, 2, 3, and then the total. So total voltage, that's something we know already. Right here, 10 volts. So our total voltage is 10 volts. Now we know the individual resistance values for each resistor. So resistor 1 is 10, resistor 2 is 20 ohms, and resistor 3 is 30 ohms. Now, if you remember from our previous video, from here we just added up all the resistors to get the total resistance of a circuit. However, you need to keep in mind that in a parallel circuit, the total resistance is equal to 1 over resistance total is 1 over R1 plus 1 over R2 plus 1 over R3, and on, depending on how many resistors you have. So let's calculate that right now. So to calculate the total resistance of our circuit, we'll have 1 over 10 plus 1 over 20 plus 1 over 30. And that comes out to, I've got my calculator here, turn it on. Alright, so let's figure that out. So we have 1 over 10 plus 1 over 20 plus 1 over 30. And what does that give us? That gives us 11 over 60. Now remember that we have to take the reciprocal of that, because this gives us, if you look over here, 1 over the total resistance. So we take the reciprocal of that, so 1 divided by our answer, that gives us 60 over 11, which, if you convert to a decimal, that's about 5.45. And that is the total ohms of resistance in our parallel circuit. So 5.45 ohms. Now let's write that over here. So total resistance is 5.45. Now, using this, we can calculate the total current running through our circuit. So we have V equals IR, therefore I is equal to V divided by R. I is equal to V over R. Therefore, I, in this situation for the total circuit, is equal to 10 divided by 5.45, which gives you 10 divided by 5.45, which gives you 1.83. And that's in amps. So let's write that over here. 1.83. Alright, so now, if you remember from the series circuit, what we could do is, since the current is constant in the series circuit, we could just write 1.83 for everything. However, this is a parallel circuit, and in a parallel circuit, the voltage is constant. The current is not constant. The current instead increases with each resistor added. So it's not like voltage in a series circuit where it drops over each resistor. Current in a parallel circuit increases every time you add a resistor, and voltage is always constant throughout the whole circuit. That will never change. So what does that mean? At resistor 1, we have 10 volts. Resistor 2, we have 10 volts. Resistor 3, we have 10 volts. Now, we still have so we still have to figure out the current for resistor 1, 2, and 3. So how do we do that? Well, we already have V and we have R. So what do? We use this equation. I is equal to V over R. So 10 divided by 10, that gives you 1. 10 divided by 20, that gives you 1/2 or 0.5. 10 divided by 30, that gives you 1/3 or 0.33. So now, sanity check you can use is in a parallel circuit, the current running through each resistor should add up to the total current. So let's check if that works. So if we clear this up, we have, what was it again? We have 1 plus 0.5 plus 0.33. And what does that give us? 0.83, which is exactly what we got last time. Now remember, we rounded these values up, therefore it's not exact, because if the exact value is 0.8348 and all this stuff. But since we rounded everything to the nearest hundredth, 1.83 works fine. So yeah, now let's do a quick review. So things to keep in mind, we have the current increases with each resistor you add in a parallel circuit. The voltage is always constant, no matter what resistor you're at. And the total resistance is calculated with the formula 1 over R total is equal to 1 over R1 plus 1 over R2 plus 1 over R3. And to solve for the parallel circuit, we have V equals IR. We set up the table. We fill in our known voltage and individual resistors. Use this formula to calculate the total resistance. And since we know voltage is constant, we can write 10 for each of these. And then we use I is equal to V over R, which is just a variation of this, to calculate the current running through each resistor. Alright, so that's it. Thanks for watching.